So let me talk about why and how we can avoid for loops in R. Let's say for loops. So please remember that we were able to generate some random number in R. Let's say I can do that from uniform distribution. Let me say I want to generate 10,000 variables in here. And here is how I do that. And I want to save it to somewhere in V. And if you want to check for how long does it take to run this part, you can just use system time in R to see it. And let's say you want to run this part and you want to see how long does it cost. So you see that we have 3 parameters as an output in here: the user, system, and elapsed time. And user shows the CPU time R needs for calculations in here. And system time is the time the system is using for processing that request in here, like handling file, the system that use in here. And elapsed is the total time. And it is like a wall clock in there, and they are in seconds, and you will see that it just shows how long it really took to process the comments. Generally, we check for that elapsed time in total. And so when we just run this part, you see that it's just getting 0.001 seconds to run this code in here in total. If you use for loops instead of that part, like this is a vector-based calculation, and if you just use object-based coding in here, you can use for, let's say E in, I in 1 to 10,000. And I'm just running uniform. And for each step, I just generate 1 in for loops. And here's how can I run that part. I think I may not this guy in here because we just have 1 line. And here is my for loop. And if I want to see the time and how long does it take from R to run this part, when you run it, you will see that's kind of different than using vector-based timing. So it's getting more time for loops. And this is a really small calculation. If you have more variables, let's say I'm adding 2 zeros, and you even wait for this part, it is getting more than 1 second. And it is like, let's say I have 164 over 0.0. It's like 50 times faster in here, like slower for loops in here. And let's see another example. And if you want to do some summation, I want to do some summation from 1 to 10,000 again. 10,000. When I run this set, this is my result in here. And instead of the result, I want to see the system time. And here is my system time. It's not getting that much time. If you want to do it as an object base with for loops, you can just write it like that. Let me write it in here. I want to do a system time again. System time. And I want to use a for loop in here. Let's add it in square brackets. And I will start with I equals 0 and for loop j in 1 to 10,000. What we are doing is that so I'm going to just get I and I plus j in here, and And as a final step, I will write print that part. And I can write it like that, I guess. For this part, I'm starting with 0. And for each step from 1 to 10,000, I'm just doing I equals I plus j and then print that part. Let's see how long does it take. And it is taking more time than the previous one in here. And this is one of the ways we can see that for loops sometimes for loops are slower in R. But this is not true for all calculations, but in these examples we can do that in faster, and you can even try different ways to write your codes in R to make it faster in here. Okay, so let's try another example. I want to generate a data frame from some numbers. Let's say I'm C binding uniform random numbers. Let's again use 10,000. And the second one is also from uniform distribution with 10,000 in here. I have my D matrix, which is a kind of big matrix. And here is my first 6 lines for I have V1 and V2 columns. And I want to find the means of each columns with for loops and avoiding for loops. Okay, let's first try for loops, and then we will try another way to run it. Here is my system time. And I want to start with for loops in here. Let's give it a name. Here is my loop in in 1 to length of D in here. So how can I find it in here is that I'm going to just get 1 to length of D and length of what? Length of columns in here. Okay, we can just find it like that. And so for each columns, I'm going to just find mean values. The mean of, let's say, the loop 1, and again, let's say D for each loop. Here is my first column, here is my second column. For each of them, I'm going to use the mean values in here, and let's save it somewhere. Okay, let's save it to somewhere in here, mean 2. Okie dokie. And here is my loop. Okie dokie. For D, I'm adding a new variable, and for each of them, I'm just saving the mean values for these 2 guys in here. And when you run this part, it's just getting 0.68 seconds from you guys. And you just change your D in here. And we added one more columns into our matrix in here. And this is how it takes. But there's one more way to do that. Okay, and again we can just have our D, and here's our D. We just overwrite it. And now instead of for loops, we can just use apply functions in here. Let's see the system time also. I want to see the system time. For D matrix, I want to add another mean column in here. Let's say I have my apply, sorry, not append. I have my apply function, and like that. Here is my apply function. I want to use D for each rows. 1 means rows, 2 means columns in apply functions. So for each of them, I'm going to use just find the mean values in here. And let's see, when you compare the times, you will see this is the This is for loops, and this is for apply function. And you see the apply function is much faster in this example. Okay, so when you use for loops, when the output of one iteration depends on the result of the previous iteration, then it's a good idea to use for loop. Please keep in mind that, okay? So when you want to make your comment like code faster, faster for your, let's say, big data, it's a good way to use some apply functions like apply, tapply, sapply. Generally, they work faster than R. Sometimes you have to use for loops, such as when you have your output of one iteration, and that depends on the result of the previous iteration, then for loops is an easier way to use in here. Okay, and sometimes apply and for loops generate different output types. Let me show you another example. Please keep in mind that, okay? They may give different, for example, in this example, they're generating similar results, but in some cases, they may generate different outputs. Let me just define a vector first, df from 1 to 10. This time, instead of apply, I want to use lapply. Please remember that you should give a list or a vector to lapply. So in here, I want to use a function of I define, okay? I'm going to use my df for each of these guys in here, I want to just do that multiplication in here, okay? So when you just run lapply in here, you will see that lapply evokes the function for each vector separately. It takes 2 first and just do that 2 times df for you, okay? And then it just run 3 times df for you. And this is what is happening in lapply, this part. Okay, when you run this part, this is what is happening in lapply. It's just giving you 2 different vectors in here. But if you use for loops, let's say again, I have my df from 1 to 10. Okay, if I use for loops in here for I in 2 to 3, similar to the previous one. Okay, I want to just do df equals df time I. Okay, and when you just do this one, if you just check out for the result, it's kind of different than the previous one. Do you see that? Now what's happening is that for loop runs the loops consecutively, okay? Then your 2 results are different than each other, okay? These 2 results, the lapply is giving you 2 different vectors as a list. The output is just a list with 2 different vectors. And so, but for loops is just running that part consecutively for you guys. So please, depending on your aim, please try to be careful using for loops or apply functions in here. So if you are willing to write loops, there are some certain rules, okay? If you are really want to use for loops, we should keep in mind some rules in here. And so first of all is that please initialize new objects to full length before the loop, okay? Rather than increasing their size within the loop. Okay, or do not things in a loop that can be done outside the loop. These are 2 loops. These are 2 rules that if you want to use for loops, and let's see what I mean. First of all, I want to generate a function. I have my function of n, and for a, I'm just generating a numeric value in here, okay? This is what we are recommending for R. You can just write it outside the loop too, okay? Or outside of the function too. And so for for loops, please initialize new objects to full length before the loop. Okay, before the loop means I'm just starting loop. In here, I will use A in my loop, but first I just define my A before my loop. So let me just run loop in here for I in 1 to n. So for each values of A, I'm just doing 2 times pi times sin I, okay? And I have my A in here. So what's happening is there for each value of A, I will just do 2 times pi and sin A from n, okay? And I defined A before, and I'm kind of increasing the size within the loop in here. And here is my function. So I want to run this function by using system time. Here is my system time. Here is the name of my function. I want to try it for, let's say, for 10,000 or even more in here. Okay, let's say, I think I wrote 1 million. When I run this part, this is what it is giving to us. Here is the time it uses, okay? So it's a good idea to define what you are feeling inside your for loops in here. And also please just do, if you are able to do something outside the loop, just do that part. Let me rewrite this function for you guys, okay? And let's say, so in here, maybe you have your curly brackets in here, I guess, yes. So if you want to rewrite that part, we are again generating a new function. Let's give it a name. It can be anything you want. And this is the function of A. So I'm going to first generate A as a numeric with a size of n. After that, I will start my for loop. So for I in 1 to n, let's write it like that. I'm going to just fill each values of my A and with sin I, okay? Sin I. So this is my for loop. I just wrote everything in here. Maybe when you just see what's happening is that, for example, these are just fixed numbers. So they don't need to be inside of the loop, because when you just check out, you see that this guy is the only one, it should be inside the loop. But for here, let's say, I can find the rest of them, 2 times pi times A, just outside the loop, like in here, okay? This is much better than that version. In here, I don't need to do these calculations inside for loop, because for each step, it's going to run this part for you guys, okay? I can run this function, so, and then try with system call, I mean system time call 2, this time call 2, and I have 1, 2, 3, 4, 5, or just, yeah, 5 and 6. And I run this part. Let's compare them. I run that one and I run this part. You see that the second one, which is not running that pi and 2 times inside the loop, is much faster than the previous one, okay? And also you can just avoid loops to produce clearer and possibly more efficient code, okay? Not simply to avoid loops. Just make sure you have more clear and possibly more efficient code, then you can just skip that using for loops in here. So I also want to show you if else, which is a very useful function we can use in R to avoid for loops and to make our codes more clear and readable. And please remember the tips data in package reshape. So let me just make it bigger for you guys. And I'm going to use that tips data in the library of reshape 2. Here is my tips data. And I can see the first 6 lines. You see that we have 1, 2, 3, 4, 5, 5 let's see the dimension instead of just counting them. And we have 7 variables and 244 variables in here. So let's assume that you want to generate one more columns to categorize your tip variable with 2 category with for loops, okay? So you want to add 1 categorical variable in here, okay, by using this tip column in this tips data set, okay? We can just first define a new column. In tips data, I want to define a group variable, which is a tip group, okay? And when you just check out for the head, and we have another tip group column in here, but I think when we fill it, it's going to work in. Sorry, guys, we should give it a name, give it a value, of course. So let's say this is 0. And when you run, now I have another column this time. By using for loops, I'm going to categorize this column, this tip column in here, okay? Let me first define the dimension of, you see that we have now, we now have 8 variables, and I want to use that first dimension, which is the number of rows. By using each rows in here, I'm going to fill this column, and here is my, you see that I can just get the number of dimensions in here. Let's say this is n rows for me, okay? This is n rows. So I will use that one in my for loop. So for I in 1 to n rows, sorry. Yes. So what we are doing is that I'm going to use if statement. If my tip I is smaller than, let's say, 3, okay? If it is smaller than 3, my tips of that tip group I is low tip, okay? Low tip. I'm just giving a new category for this variable. And here is my if statement. And another one, if that tips, and here is my variable, and my tip is greater or equals to 3, what I will do is that, okie dokie, and maybe I can just copy and get this part in here, and it's going to be high tip, okay, high tip. So for each rows, I'm going to go and check out for the tip variable and see if it is smaller than 3 or greater than 3. If it is smaller than 3, that new variable tip group is going to be low tip. If it is greater than 3, it's going to be high tip in here. Let's run this part. Okay, and when you just check out for tips, you will see that now I have low tip and high tips in here. Let me just check out for this part. Okay. Okay. I think I did some typo in here. And here is what is happening. Instead of n rows, I just wanted to use this one now, okay? And I think it is much easier to read now. And here is what's happening, and here is what's happening in here, okay? And this is my for loops, let's say. And now I just have new variable in here as a categorical variable, depending on this tip. For example, these two guys are smaller than 3 and they are low tip. And these are greater than 3 and they are high tip in here. So if you use if else, it is going to be much more easier for you guys. Let me show you how it is working. If else in here. So in if else, you are just writing your if else in here. And first thing that you have to give your text expression. And the first one is going to be, if your text expression is true, it will just get this first value, your new variable. And if this test expression is false, then your new variable is going to be that value, okay? We should see the data set one more time. And it's going to be much clearer for you guys to understand what's happening in here. And I'm going to use that reshape 2. And here is my data sets. Here is my data sets. I just rerun it. I don't have category anymore. I delete that part. And now instead of for loops, which is really too much for us, and there is one more way that we can use in here. I have my tips data and I want to add a new variable in here as tip group, okay? And here is how it is working with if else. If else, and let's see, it's going to check out for tip variable. And if it is smaller than 3, my new variable is going to be low tip. If not, it's going to be high tip. That easy, that easy. You see what's happening in for loops? It's taking too much coding, too much writing in here. But if you use if else, you can just solve it in a one-line code in this example, okay? And so when I write this part, and when you just check out for the data sets, now I just did the same job with just one-line code. I have new categorical variable, and these are low tip and high tips, okay? And also you can just, you may want to find the mean value of total bill for each gender in here, for each of your gender. We can again use that if else. Let's say I have my tips data and I want to generate a new column. Let's give it a name, mean.tip, it's a name I gave it. I want to use if else again. So let's check out for the tips data, and this time for gender, and if it is female, okay? If it is female, then the mean value for this one is going to be the tips dot total bill, and then I will go to the tips dot gender in here, and it's going to check for if it is female, and please, if there's an NA value, remove for me, okay? So we also need one more options in here, else I'm going to get the mean of the same part, okay? Same part in here. And this time, instead of female, I should write male, okay? And what is happening is that if else is just go to your codes inside the code. It's just looking for this condition. And if this condition is true, if your gender is female, it's going to go to that part and just find the mean value for you guys for this total bill. Okay, you are just looking for the total bill for each gender in here. And if this is false, it's going to go to that part and find the total bill for you for that gender in here. Okay, let me run this part and let's add tips. Okay, and here is our new column. And for each gender, I have my mean value for females let's say in here, and for males, I have the mean values of total bill for males and females. And you see that males' mean values of total bills is higher than females in here. This is all I wanted to say about this avoiding for loops and some ways to use instead of for loops and make our codes more easy to read, and also sometimes make it faster than here. And here is the reference I used to prepare some part of this video.